1.3, linear functions. We've seen linear graphs. They just make straight lines on a graph. It'll be a linear function as an equation as long as there's no variables that have exponents. There's no variables in denominators. There's no square roots. I'll stop there. So the y-intercept, from what we know, is where the line will go through the y-axis. The x-intercept is where the line goes through the x-axis. The unique thing about those, both of them, is that, well, I'll show actually. So this would be we'll pretend like my lines are straight. Let's say that this is a good straight line as well, okay? So the y-intercept is where this line goes through the y-axis. It's right here. The unique thing about that is that the x value is always going to be 0. Then you just got to find the corresponding y value. It is an ordered pair, though, so you should write these as ordered pairs. I think on the assignment it wants them as ordered pairs, so just be careful about that. And then the x-axis, where the line goes through the x-axis, that's our x-intercept. And again, the unique thing about this one, though, is that the y value is 0. How do we know that that y value is 0? Because it's on the x-axis. Remember, the x-axis goes exactly through where? On the vertical axis, which is the y-axis, is 0. Same with the x value being 0 for the y-intercept. It goes through the x-axis. So that's where the x value is 0. Okay, so find the x and y-intercepts of the equation. I'm going to set these up. So I'm just going to write x-int, because the intercept's a long word. But I know the x-intercept, the y value has to be 0. So I'm just setting up this ordered pair so I don't forget that the y value is 0. Same with the y-intercept. It's just that there is a 0 value. It's the x value. This is going to help me. This really is just saying solve for the corresponding x and y value. That's all it's really saying. Just like we saw, was it 2 lessons ago? But this means I got to use the equation. 5x minus 6y equals negative 30, and I got to solve this sucker. But the first one I'm solving for is the x-intercept, which tells us the y value is 0. Here's the nice thing about that, right? Is that that whole term becomes a 0. What I'm left with is just 5x equals negative 30. I think that's doable. So I can solve this with a principle of equality to make this 1x simply by dividing both sides by 5. So negative 30 divided by 5 is negative 6. My x-intercept is negative 6, 0. And of course, if you needed to put that on the graph, you could. So next up, now the y-intercept, 5x minus 6y equals negative 30. Even at this point, what I would do, and we know that you're going to replace the x value 0. Sometimes what I'll just do is just kind of cover that up so I don't have to look at it anymore. Because it is going to force it to go away because the x value is 0. And then we have a one-step equation to solve. Simply divide both sides by negative 6. And that will tell us what the y value is, negative 30 divided by negative 6, positive 5. I have the ordered pair 0, 5, which again you could put on a graph. And then even just connecting those 2 points and extending the line would be the graph for that. So finding x and y-intercepts, this is what we call slope-intercept form. We may get to that, but we may not today. Doesn't matter. Remember, for your x-intercept, the y value is 0. And for your y-intercept, the x value is 0. Okay, but this is just setting us up to solve this one. But they've given us values that we need to solve for, right? So we go back to the equation, y equals negative 8x plus 3. Here, though, we're replacing the y with 0 because that's the y value for all x-intercepts, and just solving this equation. So first off, 0 out that plus 3, so minus 3, so negative 3 now equals negative 8x. Guess we're going to see a fraction on this one. That's not a problem. Actually, I'll show the division differently on this one. Divide by negative 8, divided by negative 8. And that will give us a 1x, which is what we want. 1x equals positive 3/8. So it sounds like you may see some fractional answers on the assignment. That's okay too. Now, the y-intercept, this one's pretty easy in this format, which is called y-intercept. But it's y equals negative 8x plus 3. And yeah, we can see that we're going to replace the x with 0. And yeah, whenever you get something times 0, it just zeroes out. We end up with y equals 3. So that one wasn't too bad. 0, 3. And again, we have two ordered pairs that we could graph. Graphing with fractions kind of sucks, but it probably won't ask us to if it has fractional values. Graph the line that has an x-intercept of 5, 0 and y-intercept of 0, -3. This is great. They gave us the ordered pairs. So I'll start with the x-intercept at 5, 0. So from 0, it's 5 to the right. Boom, I found it. 5, 0. And the y-intercept, starting from the origin, down 3, because 0, -3, found it. That's 0, -3. And then we got to graph these points. Here we go. Hey, that's not too bad. My arrows suck, but that wasn't too bad. You'll notice that I did not extend that beyond. That's because I don't care. But you can. Like if you were like, I just need to draw that all the way to the end, feel free to. I put the arrow at the end, which tells us that the pattern continues, and I'm okay with that. All right, we got to talk about slope. Slope is like staircases. I think I mentioned this in that first lesson. So we look at these three staircases, and we say, which one is the steepest? Well, steepness is not just about the size of the numbers, strictly. Okay, so we can't say, well, 8 is bigger, therefore it's steeper. Okay, we have to look at both, and we have to look at not just like the flat platform of the step, but also how high it goes. So we're looking at both. Okay, that is what we call rise. And this is how it works. Rise over run. Okay, rise is the up and downness of the line. Up or downness. And then run is left or right. So it is a ratio of rise to run. So this first staircase, I can see it's up 5 to the right 5. That's a 5 to 5 ratio. So its mathematical slope or steepness would be 1. This next one, I can see it's up 3. So it's a 3 to the run is 8. It's a 3 to 8 ratio, 3/8 ratio, which has a decimal, 0.375, if you care. But I can see clearly that this ratio is smaller than this one, and so I know that this one is steeper at least between these two. But then we have this last one where I have a rise of 6, so that'd be 6 over run of 4. 6 over 4 would simplify, I'd just make it 1.5. You can say 3/2 if you want, but 1.5 is good. And now I can see that the one with the steepest staircase is staircase number 3. That seems like a small platform, so I'm not suggesting you build your stairs like this, but it's steep, all right? It's at least steeper than those other two. I prefer this one because I'm lazy like that. But it's all about rise to run. It's a rise to run ratio. And now when we look at these on graphs, of course, it would just be, you'd have lines in between here. And also, you're going to have endpoints on these, okay? So when you have endpoints, they're not actually going to show the staircases, but I'm going to draw them in so that we can see rise and run. Well, there's some, I just took these off the internet. Don't tell anyone I did. But these are staircases, right? And this one is going in, I think that's an actual, like this has not been skewed at all. That's a pretty steep staircase. But older homes have these kind of stairs that are very steep, very small platforms to step on. So if you have a house from like the 50s or 20s, you may see these types. Of course, this type looks pretty good, not just because it's, you know, whoever built it made it pretty, but it's flatter for me, and I like that. I don't like this one. I'd feel like I was going to fall down. But again, if you looked at these, you could say which one is the steepest, and if you had at least the profile of it, you could possibly make that decision, okay? So when a linear relationship is graphed on a line, you call the constant rate of change of the line the slope, which we already seen from the last slide it's the steepness of the line, which is a ratio of rise to run. So slope on the graph, find the coordinates of 2 points on the graph, because that's all you need is 2 points on the graph. You need to make sure you can define them though. So they need to go through the corners of the grid. Otherwise you have fractional values, which we don't want. We do not want to work with fractional values, plus you'd be guessing. Find the rise, how far up does it go? Then find the run, how far to the right it goes. And remember, this is going to be on a grid, so if you have 2 points like this, you'd say how far up the street you'd have to drive, and then how far to down this street you have to drive. Okay, rise and run. And then, yeah, it's a fraction of rise and run. So here's our graph that we got to find the slope of this blue line. But again, we need two ordered pairs that we can use, and there's three that we can choose from. I see this one. It's going exactly through that corner that'd be 0, -4. And then it's going through this corner at 1, 1. And then also this corner at 2, 6. We only need two. Okay, so choose two, any two. Doesn't matter which two, and then go with that. I'm going to choose two that are at least close together, these two. So I'm choosing 0, -4, and then 1, 1. But like I said, we want a ratio of rise to run. So I'm going to look for my rise, and I'm going to start with rise. Some students choose to use the run first, and that's fine as long as you remember it goes in the denominator. It has to go in the denominator. If I didn't specify this before, if I ever go down, then then my rise is negative. If I go to the left, it makes my run negative. It's possible to have both negative. Me personally, I always go to the right, meaning I'm going to find the point to the left and then always go to the right, making my run positive. You don't have to, though. So my rise here, I can see that I'm going to have to go up to this street, and then I'm going to have to take a right on this street. See that? But how far up does it go? Well, starting from this point, don't include that point in your counting unless you're going to count 0. 0, 1, 2, 3, 4, 5. So I'm going up 5. That's my rise. It's up 5, which makes it positive. Not that you have to show the positive sign. And then I can see I'm going to take a right there. 1. Okay, so my run is to the right. 1. And that's a 5 to 1 ratio, which simplifies the 5. That's the one we really want, just the 5. So if you had by chance chosen this point at the very end here, you would have had up 10 to the right 2, but you'll see that that also simplifies just to 5. 10 divided by 2 is 5. So the nice thing about straight lines is that steepness does not change. You'll always have the same steepness, which means and that's why it doesn't matter which 2 points you choose. You can choose any 2 points. Okay, sometimes they don't always give us a graph. They just give us the two ordered pairs. If they do give us the two ordered pairs, there's different ways to do this. I like the slope formula. There's a way I like better, but this is okay. So you can see they're going to give you an ordered pair. It doesn't matter. You can call it x1, y1, or x10, y10. It doesn't matter. They have to go together up and down. But remember, the rise is about on the top. It's the numerator. So whatever your y values are in the numerator. And then your x values, that's the runs, because not the runs, but left and right. Yeah, sorry. But the x values, that's the horizontal number line, so that's why it's in the denominator, because that's our run. Okay, and then of course they give us the second value that we can plug in here as well. So this is just plug and chug. When I put this into the calculator, I'm going to use the N/D button, and then I'm just going to plug in the values. You'll notice also that it's always subtraction between the values. That's because it's a distance. Subtraction always tells us distance between values. You could say difference because it is subtraction, but that's what we're trying to find, how far apart the values are. And we don't even necessarily need to worry about direction because it's going to tell us as we put this into the calculator. So what do we got? We got this formula, right? And I know it needs to be y1 over x1, and then y2 over x2. Corresponding values need to be directly above and below each other. I'm going to call my first point x1, y1. So I can see the y value is -7, and then I can see the x value is 4. I just plug that in. Next, I see this ordered pair, which I'm going to say is x2, y2. I can see the y value is 0, so I replace the y2 with 0, and the x value is 1. I replace that. This will give me the slope. Just got to put it in the calculator. So N/D, -7 minus 0, all over. So I push down to go to the denominator, 4 minus 1, enter, and it tells me the slope is -7/3. We did it. Here's the good news about this. Some students get confused because they're like, which one is 1 and which one's 2? It doesn't matter because it's a straight line. The steepness of the line will never change. The slope of the line will never change. So if you made this 0, 1 here and then -7, 4, you'd get exactly the same slope. All right, slope and equations. Standard form, it sucks. Because, well, it doesn't actually. As long as but you have to memorize this form. What we're going to do if we see it in standard form is we're going to change it into slope-intercept form. Hopefully this isn't a surprise, but if we change it into what we call slope-intercept form, it's going to give us a slope. The intercept it's talking about specifically is the y-intercept. In this formula, okay, so we got y equals mx plus b, mx plus b, m is the slope. Why would they use m for slope? I have no idea. I kind of assume the Greek word for slope starts with m. I can't confirm that because I don't know Greek. Also, I don't care. I guess I said that, all that stuff, but you probably don't care either. B is for the y-intercept. Welcome to math. Why is it B? I don't know. But when it says it's the y-intercept, it means that it would be the point 0 and then whatever this number is. Just remember, it takes the operation to the left as it's signed. So if it was like -5, it'd be -5. I like this format because it tells us the slope right away. Standard form, though, we have to use principles of equality in order to force it to become slope-intercept form. Or you can use this format too. Oh, this is great. Remember, I'm doing this not to be redundant, but just hopefully to help us remember. It's y equals mx plus b. Okay, so m is the slope. And b is the y-intercept. I may have to copy that down. Well, I can see up here that the slope is it's the coefficient of x, which is, in this case, -9/2. That would be, I would say that's down 9 to the right too, but it doesn't matter. And then the y-intercept, it's always going to be 0 something, so don't forget to put this into an ordered pair. But the 4 there is negative because it's going to take the minus sign as its sign. So it's 0, -4. Now, the reason why this is important is because it gives us a point. If it asks us to graph, it gives us a point to put on the graph and then the slope to find all the other points. So we could find the second point and then graph it if we wanted to. So for a problem like this, when it says identify the slope and y-intercept, no problem. In fact, some students struggle to see that this is y equals mx plus b. Okay? It is, though. It's just, you can't see the plus b. It is there. It's what we would consider a plus 0. So yeah, right here I can see that my slopes match, and then now we can actually see what the b value is, the y-intercept. The slope is just -14. You could say -14/1, so you know you got to go down 14 to the right one. But either case, the y-intercept, please don't just put 0. You should show it as an ordered pair 0, 0. One quick, so principles of equality, to force this into slope-intercept form means that I would have to take this and use principle of equality here. I want to isolate the y, so I'm going to have to add 6x to both sides. Now you see I'm putting the plus 6x below the minus or -18. Those are not like terms that you can combine, so please do not combine them, right? So that's going to zero that out as we want. I now have 9y equals 6x minus 18. Last thing I want to do is make the coefficient of y 1. So I'm going to divide all the terms by 9. You have to divide all the terms by 9. So that's going to leave us with y equals 6 divided by 9. That'd be 2/3. And then -18 divided by 9 is -2. So this tells me what the slope is. It's the coefficient of x, which is 2/3. The y-intercept, please don't say it's -2. It's an ordered pair. Yeah, make sure not to forget the 0 there, because if you do on a test, minus a point. Okay, so if you ever are asked to graph a function or equation, you need two things. You either need the y-intercept, really any point will do though, and then you need the slope. Here's why, because as soon as you can put a point on the graph, then you just use the slope to find all the other points. But these are straight lines, so really all you need is one other point. You can use the slope to do that. Now, if you have 2 points, like the y-intercept and x-intercept, you can graph the line very quickly by simply putting those 2 on the graph. So either one of these will work. If they just gave us 2 points, it'd be easy to put those on and then just graph those as well. So they don't necessarily have to be the intercepts either. So on this one right here, I have the y-intercept right there, -4. I'm going to start that. Let's start with that. y-intercept at 0, -4, which would be here. And then it tells me that the slope is 2/5. Both of these are positive, which means my rise, that's my numerator 2, is up 2. The run is positive, so that's going to be to the right 5. So from this point that I already have on my graph, I go up 2 to the right 5. That's my next point. And actually, since I'm doing it by hand, I can continue this pattern. Not only to the right, but to the left as well. I can go left 5, down 2, left 5, down 2. Boom. And you can see now I've given myself lots of points to graph with, but technology can do that too. So this is the line that I have. Okay, so what's going on with this one? I'm going to rewrite it as y equals, in fact, just make it kind of familiar. And even the x and the +1, that's okay. We know the +1, that's going to be my y-intercept at 0, 1. But what's going on with the slope here? It's negative 0.25. What I'm going to do is I'm going to change that into a fraction on my calculator. So here's what I'm going to do. Okay, so I'm going to type in negative 0.25, and I'm going to push the enter button. Okay, so I'm going to push equals, and on my calculator it just says, oh, you want negative 0.25? No problem. But what I'm going to do is I'm going to push this button. It's just directly above the enter button. It's a double arrow button, and that will change that decimal into the fraction 1/4, negative 1/4. Okay, so actually my slope, it's better to see this as negative 1/4. And you see also in this equation, I've associated the negative with the numerator. That's because I need to know where that negative should go. And it doesn't really matter which one you choose. I just always choose to associate the negatives with the numerator. So my slope m is negative 1/4. Since this is still rise over run, which is important, the rise is negative, which means it's going to go down 1. The run is positive, which I always like, which tells me I should always be going to the right. So in graphing this, we need the y-intercept first at 0, 1, which is here. 0, 1. But from there, I've got to use the slope to find the other points. Now, again, it's down 1 and then to the right 4. So that's the next point. I'm doing this by hand, so I'm going to show all the points that I can. So there's my next one, and I can copy this pattern. Left 4, up 1, left 4, up 1 as well. And then all I got to do at this point is connect the dots. I've done worse lines. In fact, I've done lots of worse lines. So, but that green one, that green line right there is the graph line equation form of this equation. I'm going to emphasize this once again. Every single ordered pair on this green line would make this equation a true statement. For example, 0, 1 makes it true because if you replace the x with 0, you get a y value that's 1. Or this point, let's look at this one, 8, negative 1. If you replace this x with 8, then you would have a y value that corresponds to it as negative 1. So all these ordered pairs, even the ones in between the points, would make this equation a true statement. So what do we do about these types? Well, you could find your own y-intercept or just ordered pair just by guess and test kind of stuff. What I'm going to do is I'm going to change this into slope-intercept form. So I'm going to get rid of that 2x. I'm going to subtract 2x from both sides. I'm offsetting it from the -6 because they are not like terms. The 2x zeroes out. I can take my 3y, drop it, which now equals, though, I still want it in slope-intercept form, so I need the x term first and then the constant second. But again, please do not combine those because they are not like terms that you can combine. Next up, I'm going to divide all the terms by 3 so that my coefficient of y becomes a phantom 1, and that's what I want. Y equals just a regular y. Again, there's a 1 there, but I'm going to make it a phantom 1. Y equals, my slope here is showing as negative 2/3, and then my y-intercept, -6 divided by 3 would be -2. So my y-intercept actually is 0, -2, and just as a little bit of a different process, I'm going to put this on the graph first. So there's my ordered pair, 0, -2. And then the slope tells me, so let's remember the slope is the coefficient of x. Again, I'm going to apply the negative to the numerator as -2/3. So we're looking at rise over run. And the -2 makes it go down 2. The run 3, though, is positive, so that will be to the right 3. From that ordered pair that we've already put on the graph, the y-intercept. So down 2 to the right 3, boom, there's my next ordered pair. Okay, and I can continue this pattern, of course. Down 2 to the right 3, down 2 to the right 3. That's all I can fit to the right. But I can copy this pattern. Just going backwards, it's the same stair step. Left 3, up 2. And we see the x-intercept, but left 3, up 2 shows us the other ordered pairs that fit. And now that I have that, I'm ready to graph the line. You know what, I'll use some technology on this one. That's okay. Now remember, on the homework, all you gotta do is put 2 points on the graph, and it will graph the full line for you. But again, if you see something in standard form like this one, you should change it into slope-intercept form. That's the idea. So let's look at unique scenarios, especially with the slope. Okay, so if a slope has 0, that tells us it has no slope. That's a flat line. It's directly, well, it's flat like this one, kind of like the x-axis would be. We'll pretend like that's flat. The equation will be y equals, and then there's just some number, which is going to equal the y value on the line, okay? And why is it y? Because the y value, the y number line is vertical, and all values that go through it would just be horizontal lines. Okay, so horizontal lines have no slope. If the slope is d and e, it tells us that the slope is actually infinite, which is a straight up and down line. It's a vertical line. The difference between the equations is going to show x equals some number. So if you see x equals some number, there is no definable slope for that equation. So for this one, it shows y equals, and so there is a y-intercept because it is a y value. It would be at 0, -957. Doesn't matter how big the number is. The slope, though, since it's a y equals equation, the slope is 0. Okay, so this one would be a flat line. And any y equals a number equations, they're going to be flat lines, no slope. This equation is just x equals, well, 2. And the reason why that is because, see how it's going through x is 2, and then like all the ordered pairs, like this is 3, 2. You'll see a pattern here. So this one is -2, 2. But the x value is always 2. What is this one? -4, 2. If you see that the x value is just always 2, then boom, we know that, at least if it's a straight line, that it's just, the equation has to be x equals whatever that x value is. And in this case, it's just x equals 2. Okay, so this one again, it's y equals a number, so we're expecting a flat line at the value of -6. I see a -6 on the y number line. It's just this flat line. It's not a perfect flat line, but it'll work. So here's a flat line, right? So right away, we're expecting y equals some number, and I can see that it goes through this y value on the y number line, so it's just y equals 1. That's it. Again, it's telling us that wherever x is, it has to be 7, and that would be along this not very straight line. I tried. It has a slope that's not defined, so it has a d and e slope. In fact, it doesn't even have a y-intercept because this would be a straight up and down line at -3/5, so it's not ever going to go through the y-intercept, and the slope is so big we can't define it. So here's our last example. Identify the information given to you in the application problem below. Use that information to answer the questions that follow. Round your answers to 2 decimal places as needed. You have 917 decorative bricks delivered to your house and set down in your driveway. You need to move all of the bricks to your backyard. You move a few bricks by hand and quickly decide that will take forever. So you go buy a wheelbarrow to haul the rest. You decide to pace yourself by hauling 5 wheelbarrows full of bricks each hour. After 4 hours, you determine that you have moved 287 bricks to the backyard. After 7 hours, you find that you have moved 497 bricks to the backyard. How many bricks an hour are you moving using the wheelbarrow? Well, that would be our unit rate. And what we're going to need here is to figure out, we're going to have to figure out the slope. Okay, so this one right here is actually asking us to find the slope. Okay, so we will find it, and we will find it because they have given us all the values that are necessary to find it. For example, they said after 4 hours, you have moved 287 bricks. Now that would also include the bricks that we started with. or that we had moved before we got the wheelbarrow, right? Because we did move some before we got the wheelbarrow. But the number of bricks is going to depend on the number of hours that have passed. So this is an ordered pair of 4 and 287. That'll be crucial because we need to figure out the slope. Next, we have after 7 hours, you have moved 497 bricks. So this would give us the ordered pair of 7 and 497. So from this information, just from that amount of information, let's move this over, I know that I can find the slope. So I'm going to use the slope formula. And remember that it's always y values in the numerator and x in the denominator, and that is for both ordered pairs. Okay, so the red ordered pair has a y value of 287. Doesn't matter which one you choose as 1 or 2. And then the x value is 4. Just remember, ordered pairs have to be directly above or below each other. So the y value for the purple ordered pair is 497, and the x value is 7. I'm just going to use my calculator to do this, which is going to, I'm going to use the n over d button. And that shows me that I have a slope that is 7, okay? Sorry, 70. Now, we need to specify this. We did find the value of 70, right? But really, it's 70 bricks every hour. And again, this is using the wheelbarrow, right? So now that we have the slope, it says how many bricks had you moved by hand before you started using the wheelbarrow? What you can do is you can say, there's a couple different ways to do this. You see after 4 hours, you moved 287 bricks. Okay, how many bricks did you move in the 4 hours? Well, if it's 70 bricks per hour and you did it for 4 hours, that would have been 280 bricks. Then you can subtract this number from that, from the 287. Okay, so in other words, let's be precise here, okay? So in 4 hours, moving 70 bricks per hour, you would have moved 280 bricks. That's 4 times 70, right? Now above it says you moved 287 total bricks. So we're just going to take the 287 and subtract the 280 that we moved with the wheelbarrow, and this will tell us how many bricks were moved before we had the wheelbarrow. So that would be, that's going to be 7 bricks. Sorry, yeah, 7 bricks. No, it is 7. And please don't forget to label your answers for these word problems, okay? This also was the y-intercept, okay, because it's the initial value. It's the value that you start with. It's the starting value. So you'd move 7 bricks, then you're like, you know what, this is ridiculous. I'm going to go get a wheelbarrow. Boom, you found it. And from there, you're moving 70 bricks every hour. Now, the next up, it says write a linear function that represents the situation. But write your equation in the form Q of t equals mt plus b. Q of t is the quantity of bricks moved after t hours. Well, all we need here is the slope, and that's the m, right? Well, we figured out the slope is 70 bricks per hour. And also we figured out the y-intercept. We'd moved 7 bricks before that. So the full expression, Q of t equals 70 times t, that's the time in hours, I suppose, plus the 7. And that right there actually would be our the function. Next up, it says find the value of t, where Q of t equals 917, right? Your answer has an ordered, should say ordered pair there. No problem. Okay, so our equation that we have, Q of t equals 70t plus 7. So this is asking us, how long will it take? That's the t. We don't know the t in time. How long will it take to move 917 bricks? So in this equation, the Q of t, now we're going to replace with the 917. So again, that's what this is telling us right here. So I'm just going to solve this equation for t. That will tell me how many hours it would take to move 917 bricks. So I'm going to subtract the 7. So that would be 910 equals the 70t. And then finally, I'll just divide both sides by 70, which will give me the final amount of time it would take to do this. But I'm going to put this in the calculator. It should be 13 maybe. Yeah, I got 13. But again, it's not just that it's 13, it's actually 13 hours. Now, in case you weren't sure that it was hours, remember all of our times were given in hours, 4 hours, 7 hours, okay? Next up, it says, after using the wheelbarrow for some number of hours, I will have moved all of the bricks in the back. Well, there were 917 bricks in the back. We just figured that out. It took 13 hours to move all the bricks in the backyard.